Welcome back. Let's do question 9D. In the diagram alongside, A, B, D and the origin lie on the circle with center C. The equation of the circle is x plus y squared plus 6x minus 8y is equal to 0. But remember that when you're doing question 9A, we managed to complete the square and write this equation in this form, because that is x plus 3 squared plus y minus 4 squared is equal to 25. Right, we did this. We got this after completing the square. And then we found that the coordinates of the center C are negative 3, 4. The equation of the line AB is given. A second circle with the equation x minus 3 squared plus y plus 4 squared is equal to 25 is drawn on the same set of axes. A student claims that the two circles touch each other in one point. Is the student correct? Show all calculations. I want us to discuss these three situations. Right. If you have two circles, one, they may overlap, meaning that they can intersect each other at 2 points. Two, they may touch each other at 1 point. Then three, they may not even touch each other. Let me just show you using diagrams. So situation one, you can have two circles intersecting or overlapping like this. Okay, then we have center of circle 1 and then center of circle 2. Now we have the distance between the two circles. Right, let's call it D. Right, if the circles are overlapping like this, the distance between the two circles is less than the sum of the radius of circle 1 and radius of circle 2. So the distance between the centers will be less than the sum of the two radii. Then situation 2, let's say the circles just touch each other at 1 point. So we have circle 1 there with center 1 and then center 2. When they touch each other at 1 point like this, then the distance D is the distance between the two centers. The distance between the two centers is equal to the sum of the two radii. Radius of circle 1 plus radius of circle 2. Then the third situation, where the circles are not even touching each other like this. You have center for circle 1 and center for circle 2. Then this distance in this case is greater than the sum of the two radii. Is greater than the sum of the two radii. So it's going to be greater than radius 1 plus radius 2. It makes sense. Let's say the radius here is 3. And then here the radius is 5. So radius 1 plus radius 2 will be 8. But find that the distance here may be 10. The distance between the centers may be 10. But here, let's say this is 3. And then find that the distance also is what? The distance between the two centers is what? Is 6. See that? It means that the circles will be touching each other at what? At 1 point. But here, the distance, this is going to be shorter than the sum of the two radii. A student claims that the two circles touch each other at 1 point. So we're looking at this situation where the distance between the two centers is equal to the sum of the radii. We have the radii. Right, let's say this circle, the center is 3, negative 4. Let's say it's here. 3, negative 4. That's the center. You see the circle is going like this. Just a rough sketch. Right? The radius of this circle from this 25. It means radius is what? Is 5, because radius is r squared. Square root of 25 is 5. So the radius is 5. 5 units. And then this one also, the radius is 5 units. Okay. So radius 1 plus radius 2 is equal to 5 plus 5, which is equal to 10 units. Now we want to find out if the distance between the centers is going to be 10 units or not. Let's check. So we're going to use what? We're going to use the distance formula. So we're going to use what? We're going to use the distance formula. Let's use the distance formula. So D is equal to x at C minus x at, let's call this point, let's call it Q. X at Q squared, square root, or the square root, in plus y at C minus y at Q squared. So it means distance is equal to negative 3 minus 3 squared plus 4 minus negative 4 squared. And then get that D is equal to 10. So it means the distance between the centers is equal to the sum of the two radii. Therefore, the student was correct. Right, the student was correct when he said that these two circles would touch each other at one point, because the distance between the centers is equal to the sum of the two radii.